Hello everyone. Today, we're going to discuss Chapter 8 of the EasyBuilder Pro user manual. In our last video, we discussed how to configure event alarms and alarm push notifications within your EasyBuilder Pro project. Within this tutorial, you'll learn how to create a new data sampling object within EasyBuilder Pro, and then display this data by using a data trend display. Be sure to check the description below for quick links to different topics discussed within this video, as well as a link to our website. And don't forget to subscribe to receive updates on the latest videos within this series. To begin, let's open an instance of EasyBuilder Pro. During this demonstration, I'm going to select CMT3072XH. But it is important to note that the layout of the features available within the data sampling object will be slightly different when working with non-CMT HMIs. Now, when you begin a new project, EasyBuilder Pro will automatically display the system parameters. This menu is where you will add the various drivers necessary to communicate with an external device used within your application. During this demonstration, my HMI will communicate to a Modbus TCP server. And so I'll select the New Device/Server button on the bottom of our device list. Within the following menu, next to Device Type, I'll select the drop-down list and search for our Modbus TCP driver. With my driver configured, I'll click OK and close my system parameters. To sample data from our external device, I'll select the Data/History tab, and on the top left, I'll click Data Sampling. The following menu contains a table that will display the data sampling objects in use within our project, as well as some basic controls that will allow us to create, copy, paste, delete, or access the settings of an existing object. And we also have the ability to export or import our list of data sampling objects as an XLSX file by using the buttons on the right side. Let's create a new data sampling object by selecting the New button, within the Comment section of our Data Sampling Objects Settings menu, we can name this object. The name is what you will see when referencing this object within other components in EasyBuilder Pro. Down below, you'll notice that there are two different modes with which we can sample data. Time-based will allow us to use a pre-configured time interval, while trigger-based will allow this object to record data when a Boolean value changes states according to the parameters configured within the mode drop-down list. The read address should be the first address within a list of sequential registers. For example, to read Modbus register 4x1 through 4x3, I will first define 4x1 as my read address. Then, by selecting the Data Format button, I can use the New button to add data points. Where within the Data Format Settings menu, I can define the name of each data point in the Comment section, and the appropriate data type and formatting within the drop-down list and the optional entry fields below. Let's add 3 data points within this menu, where each point will be a 16-bit unsigned numeric value. While creating our first point, I'll click Save to Default, which will save the current configuration of this data point so that when I select the New button to create a new data point, the formatting of this point will be as previously defined. Now that my data points have been defined, I'll click Exit to save my current configuration. And you'll notice that next to data length, we have a word count of 3. And with our data points configured, we may now add a hold and control address. A hold address will allow us to pause data sampling dependent on the state of a Boolean address. I'll leave this configured to LB0 and our mode to on, meaning that when the bit defined by our hold address is true, this object will not sample data. Below our hold address, the control address will allow us to perform various functions by setting an appropriate word value within the register or tag that we configure. For example, if I set a value of 1 within our control address, the data within the current DB file will be removed, whereas a command value of 5 may be used in situations where the HMI stops sampling data because the storage space allotted for historical data has been consumed. Once the operator confirms that the HMI has available space, they may use this command to restart data sampling. For detailed information about a specific command, displayed below the control address, please refer to section 8.3 within the EasyBuilder Pro user manual. On the top right, you'll notice a small checkbox to enable history files. Selecting this box will allow us to save a historical log of our data sampling. And the qualities of this log must be defined within the settings below. If we select all records in one file, then the data will be recorded within a single file, with the name defined as shown within the file name entry box. Although during this demonstration, I'm going to select Customized File Handling, which we can use to dynamically name each file during runtime. I'll rename the folder name to Historical Data, and then select the Settings button to define the parameters of our file handling. There are two different settings related to file creation: automatic mode, which will allow our data sampling object to create a new file each time the file name is changed. This setting is used in combination with the file format syntax below, which will name the file according to a user-defined date and time format. Whereas trigger mode will allow the data sampling object to create a new file when a predefined bit trigger is at a specific state, or when the number of records within the file reaches a preset limit. And one feature that is quite useful and only available when trigger mode is selected is a dynamic format. With dynamic format selected, we can define a register that will allow the operator to enter a custom file name prior to the initialization of a new data file. During this demonstration, I'll leave our file name configured to dynamic format, and our file name will be referenced from a 10-word string starting at LW1. It is important to note that when dynamic format is selected, the file name must be configured prior to performing any data sampling. I'll also uncheck Limit by Number of Data Records and select Register Status instead, in which I'll set our trigger address to LB1. At the bottom, we may configure the sorting method that the HMI uses to sort files. By selecting File Name, the HMI will determine the most recent file to be the file with the highest alphanumerical character set, whereas File Modification Time will allow the HMI to sort files based on the date and time each file is created. It is important to configure the appropriate sorting method when using a backup object, as the backup object will export what the HMI determines to be the most recent files dependent on how they are sorted within the data sampling object. I'll configure this to File Modification Time and then select OK to close our customized file handling settings menu. Now we still have a few additional settings to configure, the first being the Save To location. Depending on what HMI you are using within your application, there may be as many as 5 different Save To locations. These include HMI memory until space is full, which will store the sample data within the HMI's onboard storage until the memory allotted for history files is full. USB disk 1, or 2, or SD will save the sample data within the external device that you have selected. Although I'd like to mention that while the HMI samples data, and before that data is saved within the external device, it is temporarily saved within the HMI's internal memory. HMI memory 10,000 limited will allow the data sampling object to store at most 10,000 records within the internal memory allotted for history files. Upon reaching the upper limit of 10,000, the earliest 1,000 records will be deleted unless you sync this data to a SQL database. Just below our Save To location, there is a blank space that will be populated with a Sync to Database section when a SQL database has been added within your project. If you enable Sync to Database, the data sampling object will sync the recorded data on a predefined time interval if AutoSync periodically is enabled. If AutoSync is not enabled, synchronization will occur approximately every 10,000 records. I'd like to note that AutoSync periodically may also be used for an external device, such as a USB or SD card. However, if this setting is left disabled, then, like our Sync to Database feature, data synchronization will occur about every 10,000 records. On the bottom right, next to AutoSync periodically, is our preservation limit, which determines how many files will be preserved within the Save To location. It is important to note the following limitations. When within history files all records in one file is selected, the max limit is 65,535 days. When using customized file handling and USB or SD is selected, the max preservation limit is 65,535 files. Whereas when customized file handling is selected and the Save To location is the HMI, then the max preservation limit is 1,000 files. To give an example of how the preservation limit is used, consider the following. If the location is HMI memory, and our preservation limit is set to 7, then only the 7 most recent files will be stored within the HMI's internal memory, not including the current file. Now, because we have our control address enabled, you'll also notice an Enable Status Address checkbox. This option will create both a status and error register. The status register will display a code that corresponds to the status of an action that is currently being performed, while the error register will display an error code if the data sampling object is unable to perform its function due to some circumstance. You are not required to use these registers within your project, but they may be helpful depending on your application. With that said, the meaning of each code can be referenced within Section 8-7 of the EasyBuilder Pro user manual. Now that we have created our data sampling object, let's create the objects that we'll use to interact with and monitor the sampled data on our work area. First, I'll ensure that the Data/History tab is selected, and I'll select the Trend Display object within our data logging section. But I'd like to note that we can also use the Historical Data display to view both current and historical data. However, when using the historical display, the data will be listed within a table of values, as opposed to the graph that our Trend Display object will create. A trend display is used to view the data sampled by the data sampling object. Within the General tab of our Trend Display, we'll first define the name of the data sampling object that our trend display will reference. Down below, I'll configure our x-axis to time, and I'll leave the range set to 100 seconds. But it is possible to configure the x-axis to display up to 86,400 seconds of data. With my x-axis properly configured, I'm going to select the Trend tab, and I'll enable a grid so that we can reference lines on our trend display. Being that we have configured our x-axis such that our trend display will show 100 seconds of data, I'll define the vertical spacing of our grid, which is referred to as the interval, to 10 seconds, and the y-axis divisions to 4. Next, we'll select the Channel tab, and currently only our first channel is enabled, but I'll enable all 3 for this demonstration. Down below, you'll notice that each channel may have its own minimum and maximum value. These values will determine how the trend is scaled within the display. Currently, each channel has a minimum value of 0 and a maximum of 100. But I'll configure channel 3's maximum value to 50 so that we can examine the effect of this modification on the scaling of this channel during simulation. Let's also ensure that each channel has a unique color, appropriate width, and that channel visibility control is disabled. With that, I'll select the Y Scale tab and configure a Y scale for each channel. When a channel's Y scale has been configured as main axis, it will be displayed as the innermost scale, and each of the auxiliary scales will be displayed in numerical order according to channel number. Now that we've finished, I'll click OK and place this object. Next, we'll select the Object tab and create the numeric objects that we're going to sample. This is not a requirement, but it will allow us to display some data other than 0. To do this, we'll select a numeric input object, and within the read/write address, I'll ensure that my Modbus device is selected and configure the address to 4x1. Within the Format tab, I'll ensure that the device data format is set to 16-bit unsigned, and then I'll click OK and place this object. Now, let's copy this object 2 times, and I'll readdress the first to 4x2 and the second to 4x3. We should also create a toggle switch addressed to our hold address, which is LB0, as well as a setWord object addressed to our control address to clear data within the current file. The control address is LW0, and a command value of 1 will clear the current data. Before we sample data, we need to enter a file name. The file name is referenced from a 10-word string starting at address LW1. So we'll create an ASCII object with this configuration. After we enter our file name, we will then use our register status address, which is essentially a trigger address that we can use to create a new file with this name. I'll create a second toggle switch for our register status address and address it to LB1. With that finished, I'll clean up my work area, add some labels, and then we'll run an offline simulation. With our simulation running, I'll enter a new file name into our ASCII object. Let's call this file1. And you'll notice that after I define a file name, our trend display comes to life. Now let's enter some data. I'll enter 15 into channel 1, 25 into channel 2, and 40 into channel 3. Remember that we have also modified the upper limit of channel 3 to 50. This differs from both 1 and 2, which have an upper limit of 100. As such, the graph of channel 3 appears to be scaled much larger than channel 1 and 2 in relation to the height of our trend displays. The upper and lower limits are also shown on the Y scales of our graph. Let's test our hold toggle switch, which will pause our data sampling object. Now let's use our clear setWord to clear data within this file. Since a CMT's trend display will show both history and real-time data, we can see that our data log no longer has our original data. This verifies that the clear command was successful. One of the many advanced features available on our CMT and CMTX series is the ability to modify the scaling of our trend display in real time. We can do this by selecting the arrow. This will display a small selection of various zoom functions. The top two can expand or contract the vertical scaling, while the bottom two can expand or contract the horizontal scaling. The option within the center of our display will ensure that the trend returns to its default state. Before we examine the gear icon, which will open the menu of our trend display, let's create a new file. To do this, I'll change the file name to File2, and I'll use the Register Status toggle switch, which I have labeled New, to create a new file. Now that we have created a new file, let's open the menu of our trend display by selecting the gear icon as mentioned. The trend display and our historical data display can show both real-time and historical data on a CMT or CMTX series. Within our file selection, we'll find that we can view both File 1 and File 2 by simply selecting the appropriate file within this menu. And of course, we can also configure channel visibility, enable or disable Y-scales, or even disable Y-axis scrolling. Now let's close our simulation and configure a SQL database so that we can sync data from our HMI to our PC. To do this, I'm going to select the Data/History tab, and on the top right, I'll click Database Server. Within the following menu, I'll select New, and we'll add a new MySQL server to our project. Within the Server System drop-down list, let's ensure that MySQL is selected, and with Use IP configured in our drop-down list, I'll define my PC's internal IP 127.0.0.1. Next, I'll configure the user account and database. And within the Status/Control tab, let's ensure that the status address is configured such that it does not overlap any of the registers currently in use. I'll configure this to LW11. With that finished, I'll click OK to save our settings and navigate to our data sampling object, where I'll reconfigure our history settings such that all records are saved within one file. Then I'll ensure that HMI memory 10,000 limited is specified as our save to location. After which, I'll enable sync to database, and we'll run another offline simulation. With my simulation running, you'll also notice that I have a local MySQL server set up as well. Now, the only prerequisites to performing a sync to database is that we have all records in one file selected within our data sampling object, and that there is a valid MySQL user account configured within EasyBuilder Pro and our database. We will also need to define the schema that our data sampling object will sync to. In this case, our schema's name is July. With this configured, the HMI will build a table within the database and sync the recorded data. I'd like to note that because I did not configure our data sampling object to sync data automatically, I've added a second setword object that is addressed to our control address, and it uses command value 2 to sync data. Let's let our simulation run for a second, and then we'll use our setword to sync this data to our database. And with that, I hope you've learned a lot within this introduction to Chapter 8 of the EasyBuilder Pro user manual. If you found this tutorial helpful and would like to see more, head on over to our channel to check out the latest technical tutorials. Feel free to check out our website as well for free demo projects, user manuals, and more. Thank you for watching.